Hello, everybody, and welcome to Handmade Hero, the show where we code a complete game live on stream. I tell you what, there's not a lot of mystery as to what we're doing today, because yesterday we did a spatial partition for our sorting, and we didn't get a chance to use it for anything, because we finished just when the bell rang. So today on day 310, we are just going to go use it. And so if you want to follow along at home, day 309 is the source code to start with. That is the source code that I am starting with right now. So if you would like to be, if you would like to be in sync, and I don't mean the bad boy band, that was clearly just a ripoff of the Backstreet Boys, a fine group of upstanding gentlemen. I mean in sync as in synchronization. Anyway, point being, here we are in the render code, ladies and gentlemen. I don't mind telling you that down at the very bottom, hiding in plain sight, there is a sort entries call, and right now we are doing a build sprite graph operation up here, and you can see it. And it is doing the work of putting grids together for sorting purposes. It's spatially partitioning all of the sprites on the screen into a grid, but it doesn't actually do anything with it. It then goes ahead and runs the old code because we didn't get a chance yesterday to go and actually make this code use it. So what we'd like to do today is make that code actually use it. Unfortunately, before we do that, there's probably one or two things we should do as well, which is turning on viewing of the sort graphs, for example, because right now we would not really be able to see the fruits, the sweet, sweet fruits, the sweet blossoming virginal fruits of our labor. So if we just kind of pretend that this isn't happening for a minute and go back to the Win32 code, we should be able to turn on global sort groups here. I guess I could have used the UI for that. But anyway, turn it on permanently so we can kind of see them all, and we can kind of get an idea of what's going on with them. It's kind of hilarious how just not clipped our sprites are. It's going to be nice to switch to a new asset pack and have properly clipped sprites at some point here, because especially with the software render, man, look at all that overdraw that we were doing for no real reason. Anyway, you can kind of see what's going on here. You can see the sort of various lines indicating who is overlapping who and all that sort of stuff. And you can see that we're actually getting pretty good sorting with most of the stuff that we were expecting to. And we still have a few things that we haven't actually implemented yet in terms of passing data down to this in a reasonable way. But for the most part, it's pretty swell. It could even rely on the sorter to sort of handle these a little bit nasty things where I'm going in front of other sprites and that sort of thing, in addition to the ground tiles and all that stuff. So it's kind of doing what we want. I'm pretty happy with that because it's a bit of a gnarly, underspecified problem, the 2D sorting of it all. Anyway, so now that we've got something that looks right, meaning, okay, we know we can see what we're supposed to be getting. When we switch to the optimized version, we'll at least have some way, before we do any sort of visualization of the optimized version, we'll at least have some way of seeing, is it doing anything at all? Like, is it even remotely close to what we had before? Because we could have all sorts of bugs in our optimization pass, obviously. So you can see here when we do build sprite graph, we've got the situation where we're going through each of these grids, and we're looping through all of the places that we need to insert. Now, rather than do this in a second pass, I don't know that there's really any reason to do it in a second pass. It seems to me like the easiest thing to do would be to actually just loop through all of the things in each grid when we do an insertion and do the check then, because why wait till later? We're already right there. It just seems like the obvious time, right? So yeah, so let's go ahead and try that. Let's go ahead and say that here we are with our, we've got our node index A, that can stay exactly as it is. But then in here, instead of just doing the simple sort of chain to the front operation, which, obviously we know we're going to do, maybe we can just, before we do that, we can just, or I guess it actually doesn't really matter. But before we actually insert, and before we actually do this insert here, we'll just loop through all of the sort grid entries in this particular grid. So this is going to be entry B, and it's going to start out at the grid location that we're on. And then we're just going to loop through each of the elements in here. Now at this point, we then have exactly what we need to do our operation that we were doing before. So we can just go in here and say, you know, and in fact, I can do a little thing that's like pound define accelerated sprite sort 1 or whatever. And then I could come in here and say, all right, you know, this operation is the operation we want to do if we're going to do accelerated sprite sort. And then this operation is the operation we're going to do if we aren't accelerated. So here I can just say, like, if we're not trying to, you know, if we're not doing accelerated sort, then do sort of this slow n squared version that doesn't try to do any sort of restriction. So yeah, so if we do accelerated sprite sort, then we're going to come through here and we're going to check each of these entries. And in order to do that, I've already got sort sprite bound A, but I'm going to have to get sort sprite bound B from the entry itself. And that should be pretty easy because I'm pretty sure what we did for node index B. I don't know why I left the entry pointer on there. There we go. So node index B just comes out of whatever the entry is in the grid at that point. I don't actually remember what we decided to store in this grid. And I also don't know why I didn't put it in the H file. The whole reason I have an H file is to put stuff like this in it. All right, there we go. Gotta get rid of that. Get rid of that errant bracket. All right. So occupant index is all we need from there. And then we can do exactly what we were doing before. We can test for the two intersections of A and B. We can then do the front back, and we can, I don't know why I have re-enable the push still in here, because the push has been re-enabled for some time. Ladies and gentlemen, this is why you never comment code, because it always goes out of date. Anyway, so now in theory, accelerated sprite sort can be set to 0 or 1. It's now set to 1, and well, that's not a very good sign now, is it? Not off to a good start. Not off to a good start. So here we are in our loop. That seems like we've got an odd sort of issue here. It looks like we've created a linked list that just kind of loops in on itself. Am I right? Let's take a look here. Well, why do my eyes deceive me here? This says that, oh, oh, there's a good one for you. I hope it's not going to be that kind of night. Yeah, gotta love it when you mistype that one. All right, anyway, let's try that one more time. Yeah, if you never actually update the iterator, unsurprisingly, you don't get very good results. All right, so you know what I'm seeing here is it looks like we didn't make any obvious mistakes with the accelerated version. You know, it's certainly not obviously wrong. It doesn't mean it's right either. Let's take a look here, though, at the profile. So one of the things you'll notice about the profile, of course, there's a tremendous amount of OpenGL nonsense in the way, but we're already much faster than we were, right? So that's a good start. So let's go ahead and turn off the sort drawing and just take a look at what we've got, because it'd be nice to know how close we are to good or at this point. All right, so there's the profile. And so you can kind of see that build sprite graph is still a little bit probably more expensive than we would like. It's still taking 50% of the time, which is probably too much of the time, to say the least. So it's not like that's a great routine at this point, but it's certainly getting better. right? It's certainly better than it was, and you know, who knows? We've got some things we could play with as well to see what we want to do. So, you know, I don't want to belabor the issue certainly, because, like I said, we don't have to worry about how long it takes to draw the debug information. But I do want to just for, like, you know, fun, I do want to look at one more thing. I would like to just go like, okay, while we're in here and playing around with it, let's go ahead and do a test of which part of this, or rather, let's do a quick test to see what the accelerated sprite sort does if we give it a bigger grid to work with. So a grid with more cells, if that makes sense. So if we were going to do that, we would say, okay, you know, maybe instead of 16 by 9, let's double the count there and just do 32 by 18. So that now there's more buckets to sort inside. And so, you know, maybe that helps, maybe it doesn't help, it's hard to say. It certainly decreased the time, right? So it looks like we were still having sort of a little bit of the n squaredness there. And, you know, who knows, we could take that up even further if we wanted to. There should be a breaking point somewhere here. And the reason there's going to be, or I shouldn't say there's going to be, the reason I would anticipate a breaking point is because the act of inserting things into cells gets slower the more that there are, right? And so you can see that, you know, again, that maybe did get us a little bit more there, but it's not necessarily as drastic, certainly as the initial one. So that's a lot better, and it's enough better too that, you know, I don't know that I would care too much about doing anything further. This is not an optimized build, so we can also, you know, sort of count on the fact that when we're talking about actually doing this hardcore we'll get a lot better performance. So, you know, this is still compiling all the debug stuff in, and, you know, now you can see that our build sprite graph is down way below even the time it takes to wait for stuff to happen, right? So I do wonder too there if the case is, well, you know, this is sort of a little bit perf critical. And, you know, a lot of the times that clearing stuff, I think part of, we pay a high cost in debug mode for the clears, it seems. I don't really know. It's a little weird. But since we do know that, like, sort of we've got these operations here, like, that we're doing that could be potentially a little bit costly, I do wonder if we come in here and sort of clean this up a little. Like, those push structs are probably kind of much more expensive than they should be in debug, because a lot of stuff probably gets compiled out in there. I'm not sure exactly, but yeah, you can kind of see it does get a little better. But I don't know, like, in general, there's a lot of business in here. I'm a little bit tempted to push it a little bit further, you know? I'm a little bit tempted to say, hey, you know, maybe we should go even further with that and, you know, try to make it a little bit less try to maybe reduce the number of things that are in here. I mean, I'm looking at it and I'm like, not really sure. I don't feel, you know, like, the nice thing would be if we could sort of build the topological sort as we go, but I don't really know how plausible that is. Like, in other words, there's a question of whether or not we really need all of the chaining, and or whether we need the second pass, you know? But I'm not thinking of anything obvious. So I feel like maybe that's enough for now. I feel like maybe that's enough. So I'm going to leave that. And we probably can say, well, you know what? We can get rid of the old version here and just say that's what we're going with for now, and off we go. Now, like I said before, we obviously have sort of a problem here that we could choose to address or not address. I don't know whether we should or not. And I alluded to it yesterday, and, you know, it's not going to cause us any practical problems unless we need to actually break cycles more logically than we're doing right now. You know, if we keep ignoring the fact that cycles could be problems in legitimate things that we hand our sorting algorithm, right? If we ignore that part, then we don't have to worry. But if we're worried about having to detect cycles for something other than just some debug checking, where we don't really care, then we do have a problem of cycles getting created by the fact that we're adding things multiple times potentially. Because since you could place yourself in multiple grids, we sort of have this problem where we don't necessarily know whether we've already visited somebody on this run, or if we've, you know, well, let's put it this way. I feel like it's probably worth showing. I don't know that if this were the real world, I would care about this, but since I can think of some fairly trivial ways that I would fix this, maybe I should just go ahead and fix this so that you can see what happens with the cycle determination. So let's go ahead and turn this on. And if you remember, what we did is we made it so that cycles, when cycles happen, we change them to be bright. You know, the sort groups get bright. And I believe that previously, you know, there were not so many cycles. You can see there's like tons of cycles all the time. Almost everything's bright. And I think that basically what we're seeing there is exactly what I just said. It's the fact that since we now have multiple grids, and I'll draw this out for you. Since we now have things in multiple grids, right? If this is A, then A exists in each of these. That's just what's going to happen. And so when B comes along, and you know B is maybe this rectangle, then what's going to happen to B is it's first going to check for overlaps in this cell, and then it's going to check in overlaps in this cell. And the reason that it's going to do that is because it spans both cells. And so in order to find all the people it might be overlapping, it has to check both. Otherwise, it might miss somebody who was only in this cell, let's say C, right? If it only checked in this cell, it wouldn't see C, and then we wouldn't have the correct sort. We'd be missing some of the overlaps. So given that that's the case, the question is, what happens when we then go to link these up using the comparisons? Well, when B checks and it sees A in the list of cells, in the list of sprites in this cell, and then later it checks it and sees it again in this, it doesn't know that it's a different A. It doesn't know that, right? It doesn't know that it's the same A. As far as it knows, it could be a different rectangle because it has no markings. It doesn't keep track of what it visited. And how would we even do that, right? We have to like a hash table or something where we put the index in that we visited or something like this. It would be expensive just to do. And so the question is, how can we avoid adding a second edge in that case? Because the first time we're going to add the edge, once we already add an edge, we don't want to add an edge a second time because it's the same pair, right? So what are we going to do, right? Well, what we need, and we could go two ways with this, right? There's a more theoretic way, and that way is usually not so good in practice if you're trying to do things quickly. And that's just like, well, you know, we could have done our edge stuff as a tree or a hash table or something, right? Where we just put edges into this storage structure and then we pull them out later, and it's not designed for quick traversal, like a little like linked list right off the thing or array or whatever, right? And if that was the case, then when you said, hey, there's an edge from B to A, it would go into that, structure and it would collide and go, oh, I don't need to add that because I've already got it or something, right? So you could imagine doing a more versatile, more theoretic graph structure. But, we're not really looking at that kind of a thing here. We're trying to make a little tweaky, fast little thing that just runs on the back end of the renderer, and we don't necessarily want to go down that route because it doesn't seem very fruitful. So what we would like is some hackier thing that's just right there in the data structures themselves in a very easy to poke at fashion. We would like some way of saying, hey, let's not add another edge here because we already added an edge, right? Okay. So I think, or at least I would suspect, that this is not going to be particularly difficult to solve. And the reason that I say that is if we take a look at what's going on in these data structures here, we have two passes, right? We've got a pass that adds edges and then a pass that walks those edges. And so, we've got recursive front to back here, and that's going to walk these things. And then, we've got this thing that actually adds them in. And so when we're adding them in, we've got node index A, and we've got entry B here. And we're about to do a test to say, do these two rectangles intersect? Well, what we'd like to say is something more like, if I haven't already checked this rectangle and the rectangles intersect, then I will add that struct, right? That's what we actually wanted to say. Oh, and by the way, did I just remembered? Yeah, I just want to make sure I change back to debug mode. So we need some way of computing that if I haven't already checked this rectangle. Well, what do I know about these rectangles, right? When I am doing insertions for node index A, I know that the entire time I'm doing insertions for A, I'm going to be looking at people who aren't A, right? I'm never going to look at myself because I haven't added myself to the grid square yet, right? So all of these people are people that I haven't visited on the node index A trip yet. And so I just need a way of marking them to say I have visited them on the node index A trip, right? That's all I really need. When I then move to the next node index A, the next setting for node index A, I then need a way to say, okay, check, I want to know now if this pass-through has ever touched any of these people. So we have, a pretty easy way, I think, to make this work, right? We've got these sprite flags. We've got visited, drawn, debug, box, and cycle, right? Well, it wouldn't be particularly difficult for us to just move those up, right? We wouldn't even necessarily need any additional space, right? I could just say, okay, pretend that these are up in the high area. So let's put them, here or something. Right? So now what that leaves me with is the entire bottom part is free for me to store stuff, right? I've got 24 million or some odd, I don't even know. So I've got what is it? 24 bits there. I've got 24 bits. So I got 24 million sprites worth of indices I could shove into the bottom bits. And if I needed more than that, well, really I could go up even another bit if I wanted to. In fact, I don't even know why this looks like this. We could just do that, right? If that makes sense. And I don't know if enums technically can't be U32s. I don't really care. We'll see if the compiler complains. OC++. But point being, so, there's a massive amount of space we've got there that we're not using. So what I could do is just say, okay, there's an index mask. And I could use that index mask to mask off the bottom bits and use them as a generation count, where the generation count is just whatever the node is that I'm on. And so then when I go to check someone, I can easily tell whether I've checked them this round or not, because if the bottom of their flags, right, if the bottom of their flags doesn't have my number, my node index A in there, then that means I have not checked this person yet. So what I can do here is say, like, okay, if I were to take the entry or sort sprite bound B, and if I were to take the flags in that one and say and them with the sprite index mask, if that's not equal to my index, then I haven't touched it yet. Right? Anything else, and it's not correct. If I get in here and I find that I haven't touched it, then I could just say, well, let's just go ahead and set the B flags equal to it. And by the way, I don't really have to, I could assert just to make sure that it'll fit. And that's just a little assertion to say, oh, if the part that if the mask that I'm using to store this would actually get rid of any data in the node indices, then that's obviously a bad thing. In order to get there, we'd have to be way up in the, almost to the billions of sprites, and that would make this algorithm run so slowly that it wouldn't be 60 frames a second. I can guarantee you that. So not a particularly big deal there. But we can also, if we want to, even though we did an assertion here, we can also, I guess, assert that no one has tried to use any of those flags since then, just in case this algorithm changes. But we could say, like, oh, assert that if I and, it with the not of it, so I look at the parts that aren't indicated by the mask, make sure that there's nothing in there. So that would give me that sort of marker that I need, and hopefully you guys kind of saw, awesome, love that texture download. Hopefully that would give me all I really need to make my cycle detection correct now, because now we've done it. And you can see it spazzing out right exactly in the same place as it used to when there actually is a cycle, when the guy goes through the thing. So, hey, good job us, right? So I hope that made some reasonable sense. I don't know, I guess I usually don't check the stream for questions at the time. So I guess if you have questions about what I just did there, ask them at the end. But hopefully it made reasonable sense. Essentially what we're doing is we're just, every pass through when we're checking for a particular rectangle, a particular sprite rectangle against all the other rectangles in its areas, we're just going, hey, every time we check someone, tag them with our index. And if we see that that index is there already, well, then we know we must have already processed it. And if not, then put the tag on so we'll know that we did. And, if the algorithm was completely unstructured and we were testing anybody against anybody randomly, this sort of trick wouldn't necessarily work, because you would need to store for every node which nodes had tested against it, right? We would have to actually store everyone who had tested against it and check to see when we come through. But because we know we check one sprite rectangle against everything in its area and then move on to the next one and check everything in its area, then we only need one tag, because all we need to know is, did we do it on this pass through? Because we're never going to come back and check this rectangle as the primary rectangle again, right? So now we're in real good shape, I think. And I'll go ahead and turn off the sort drawing one last time. But, I don't think there's really a whole lot else to do with the sort at the moment. It seems like that's pretty stable and, works real nice. And you can even see that, looking at the profile, this is not scientific, obviously, but eyeballing it, I think we were up around 22 to 24 milliseconds before, not adding those extra edges, right? saved us some time in debug mode as well, because it's not pushing on extra edges that it doesn't have to do. And in release mode, I think those edge pushes become fairly cheap, right? So it's not like a real savings in the sense of the shipping version of the game. But I like to keep the debug version relatively fast, especially on Handmade Hero, because we like to step through the debug version so I can show you things in the debugger. And as you've seen, the debugger can't handle debugging release code hardly at all. And so it's very hard for me to do anything instructional, if I don't have the debug version running relatively fast. So that was kind of a nice bonus, right, that we got as part of making those, not pushing on redundant edges that we don't need. We now get this sort of bonus of, hey, even when we stress the system, we drop off of 60 hertz, but we don't, not very far. Right, we still have a pretty darn good speed profile, even in our jankiest state. All right. So I'm not sure what we should start on here. I should probably save starting on anything too major until the beginning of the stream next time around. So yeah, I think maybe. One thing that we do kind of need to do, maybe I could get this done in 30 minutes. I'm not 110% positive. But I've got 30 minutes. One thing that we haven't really looked at yet is we have not really looked at how we would go about making suggestions to the sorting algorithm if we wanted to. And I'm not sure... I'll be honest, I don't really know what the way is that we most want to do this. Because there's a couple different things we could do. So let me just give you a little bit of an example. So let me label this here. This was grid sorting. But anyway, let's move down here to... manual sort override. Now, it may become clear to us after we do some work with the actual game assets a little further down the road that we don't really need anything like this. I don't really necessarily know. But I do certainly know that the possibility exists that we will need to do some sort of manual sorting override. And the example that I've already sort of used for this in a couple cases, right, is the hero sprite. So, we've got this hero sprite, and in the future, it definitely looks a little more, I mean, you saw, right, what they looked like on the Molly Rocket blog. We're definitely more top-down. You can see here on this post as well, you can see what the hero kind of looks like. So Anna has definitely gone ahead and really solved a lot of our perspective problems for us, so that was kind of nice. And it's going to be a lot easier to keep that the art looking consistent with the new art than it was with this art, which is really kind of not... It doesn't really work with the way we were doing the sorting, so it was very fake. Whereas this is a lot more consistent, and it has a lot more of a consistent perspective feel to it across the assets. So given that that's true, we may get out of jail free a little bit more than we would otherwise because there's such a strong perspective to it now. But in the case where we have something like that, okay, we've got the glove here or whatever, the punching glove. Well, actually, people's thumbs are on the inside, just in case you were wondering. It's not like that, maybe? I don't know. And we've got the glove, and then we've got the head here, right? Here's the nose, very important. And maybe there's a hat, because there was a Steam sale. So we've got this situation, and we know we've got hat, we've got head, we've got body, and we've got glove. And we maybe know that, okay, the glove is going to move all around the body and punch and stuff. And so that probably wants to be sorted normally and go behind things and whatever. But this pretty much always looks like this. It pretty much always goes hat on top, right? Then head, and then body. And it's never going to go any other way. Like, you really can't ever do anything else until the head disaggregates from the body. Like, if you get some magic spell where you float away and they were separate entities, maybe. But while we're talking about one coherent entity, where the head and the body are together, I shouldn't say one coherent entity, one coherent system. When they're together and they're, in the brain, it's working on head and body together. It's not clear to me that we will always get reasonable results if we just let the sorting do its thing. Now, maybe it would, but maybe it won't. Because if you think about what would happen here, if these are Y sprites, then as the head moves like back, it's going to go behind the body. And as the head moves forwards, it's going to go in front of the body, right? And that's not really what we want to have happen. So I don't know to what extent we're going to need to go in there and say, this is stacked in Z. These are actually stacked in Z, even though they're Y sprites, right? And we don't want them to necessarily not be Y sprites, because we do want that crazy 2.5D nonsense where the glove can go behind it and in front of it, right? So it's kind of a difficult problem. And so the question here is, how do we want to deal with that sort of manual sort override thing? Where we're saying, well, all right, we don't really want these to be sorted using our sort rule, because we know our sort rule is a hack, and any sort rule that we come up with is going to be a hack. And so we're going to need some ways to work with that hack and make sure that it doesn't cause critical problems like we would have in this case, I think. Now, one thing we could do is add more hackiness to the sort rule, meaning we could say, well, we want a sort rule that's a little more generic, so maybe we have this idea that there's Z-planes of the Y sprites, so they stack whenever. Yeah, I don't know. That was a really nasty gray area, and I'm not sure that there's really all that much to be mined out of that. Sorting these 2.5D things is a real pain in the butt, I guess is what it boils down to. And I don't know that there are all that many good solutions there. So I would be more inclined to look for a way of saying, when we know how something has to be sorted for artistic purposes, can we just specify that directly so that it will always happen properly, right? So there's two ways we could do this. And here are the two ways that I think we could do it. One way is we could say there are edges, right? Edges added manually. So there's some way to like shove down the render, as the render is going, the render queue is getting filled. In addition to putting sort sprite bounds in there, which is what we're putting in there right now, we could also put in there edges that we want to be mandatory. Like, they don't have to overlap. They're just edges that already exist there, right? So when we go to process something, and we're going to do an is in front of operation on it or whatever, there's another way that we could come to that conclusion. Rather than having to test it, we could just add an edge automatically that says this is in front of this, and don't process an intersection between these two things, right? There's some difficulties with that, certainly. One of them is easier said than done, right? We want the bookkeeping on that sort of thing to be fast, and it's not clear exactly how. Adding the edges wouldn't be hard. Avoiding having the sort come through and re-add more edges you didn't want is the hard part. So it's the suppression is the harder part there, right? But, are there ways around that? Probably. Probably. And it would also depend on how much of this you needed to do. If you only needed one edge, one manually specified edge per sprite, one is in front of, if you will, per sprite or something like that, it's a lot easier than if it's many. If it's like, oh no, we've got to have 10 for some of them or something like this. So I don't know. So, that's one way. Another way of doing it is basically having a way of saying these sprites get drawn as a group and don't sort them, right? And that has some attractiveness to it. The reason that's a little bit attractive is because we sort of know we probably want that anyway. And we could even you could imagine making this a fairly flexible system without too much work, where we could even keep sorting within the groups themselves if we wanted to. So you could imagine you've got a sort sprite bound, and it says this is a Y bound, and in it you could stack some Z sprites and say sort this first, then wherever it's going to get drawn, you draw whatever's inside it sorted by some other criteria, right? And it's not out of the question that we could do that. I don't know, because we're using a grid acceleration scheme, I don't know that there's really all that... Oh, all right, apparently I'm very tired. Because we're using a grid acceleration scheme, it makes it a little bit trickier. And the reason it makes it a little bit trickier is because we kind of have this one acceleration structure we kind of want to pass everything through, and we don't really want to have to deal with a lot of fussing there, right? So if we have to do sort of sub-regions of sorting, well, it wouldn't be too bad if there's only a couple things in it, but, what if we wanted to do it for, like, say, the debug thing, where we're just saying this is one layer that gets sorted separately and then drawn on top, or whatever else, right? And the same thing is going to be true for, for room layers. And so, to a certain extent, we're going to have to kind of deal with that sort of coarse grain multiple sorts. And I just don't know if we want to start having lots of little sorts happening in there. Oops. Oops. Apparently I can draw with the eraser. Didn't know that. So yeah. Really what I need to do is go take a nap. Well, probably just go to bed. I don't know. I don't have a real strong opinion on this. I think the thing we probably would want to do is, because I think it would be relatively simple, if we just have the sort sprite bounds potentially have, runs in them, essentially. Like, if I pop over here to the sort sprite bound stuff, we've got this structure. It's a little fatty right now. It's got a little bit too much in it, right? There's no question about that. But, maybe someday we need to kind of go in there and clean that up, make it a little smaller. It's true that probably, the sprite edge, this could instead of being pointers, these could be indices. That would crunch things down a little bit. The rectangle too for screen areas, taking up a lot of space. And some of that could possibly be harmonized with the sort key. I don't know. There's just, it's tricky, right? So I don't know. So right now it's a bit overweight, it's true, but certainly with respect to that part of it, it wouldn't be a big deal probably to say, hey, why don't we just add a count in addition to the offset, right? Why don't we say, hey, we've got these offsets in there. Maybe there's an additional piece of information that's like a chain there. Or the other thing I guess that we could do, right, is actually chain things together. So, if you take a look at the render group entries themselves, it's a union, right? It was a union. Where is union? Thought it was union. I guess everyone just puts the header in there. I guess that's interesting. So I guess we didn't actually implement it that way. Oh, right, because I don't actually use it as a union. I actually pack the things. Wow, that's dedication. Anyway, so point being, we've got these render group entries, right? And it would be pretty easy for us to say, well, either all of them, if we put it in the header, or some of them, in the case of, like, maybe we only care about doing this with bitmaps, because that's really the only thing we tend to draw that we care about or whatever. I'm not sure. Probably wouldn't matter, because if we're going to put it, we might as well put it, since most of our things are bitmaps, we might as well put it up in the header, because it's pretty much always going to be there anyway. We could just say, here's another offset to go read after this offset. And if that offset's 0, then you're done. But otherwise, there's sort of a chain of these things that you can follow to, like, draw more. And so most of the time that wouldn't happen, but any time that we did have something where that thing was non-zero, you could draw a bunch of things at the same sort level. Right? It seems like a pretty easy solution to do something like that. So you'd just say, like, oh yeah, there's, you know, next offset on here, you know, and we could say, you know, if non-zero, then jump here and render and continue rendering entries. So we could kind of just chain things through there on the cases where we want things stacked in a particular way that doesn't involve any kind of sorting, right? So if we wanted to do that, let's see what would happen. First of all, we would have to actually obey it. So inside the renderer, you can kind of see the way this works, right? We have this sort entry thing happening here where we loop through the various entries that we have. And the way we do that is we've got the sort entries and we pull them out. We index, we get the indices, and once we pull out an index, we do the processing on the header like this, right? And so we could say that we got the offset, you know, this way, right? So what we could do here is say, you know, let's go ahead and see what it would be like to add chaining into this. And it seems like it wouldn't be particularly hard. We could say, you know, let's call this header offset. Let's say that we got it this way, right? I could then just say, do what's in here, you know, this whole nice fancy schmancy nonsense that you're doing. Go ahead and do that, and do it while header offset is not equal to 0. Now, obviously, the first time through, maybe header offset can be equal to 0 because the first one. But if we start chaining, we know you can never chain back to the 0th one, let's say. That's just not allowed for whatever reason. I guess that would mean we'd have to reserve the 0th element. In that case, I suppose we don't even really need the do loop. We could just do it like this. And let's take a look, actually, to make sure that that's the case. Let me see what actually happens there with the offsets, but I'm going to go ahead and add a thing that just asserts that 0, because that way the loop looks a little cleaner too, and we should reserve 0. I like to reserve 0 most of the time just to make things cleaner, almost always. So I'm going to add an assert in here that the offset is never 0. Right, yeah, we'll have to do a little bit more work here. But anyway, inside the header, we'll do next offset. That's always equal to 0 as well. So, blah, 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 such and so forth. Everyone is happy and whatever. People do things, and it's great. And I guess, you know, to be honest, we probably don't want to use a for loop here because we're going to pull out of the header after we dereference it, so I can't really be quite that slick. So I have to do while the header offset is, you know, valid. But once I know that the header offset is valid, at the end of it, I could say, you know, after I get it out, I can say header offset equals header next offset, and then I've got my daisy chaining. So it's a pretty easy thing to do. It's easy to add to both of our render dispatches because, you know, they both basically work, you know, more or less the same way. So if I want to, I can just have my daisy chaining and I think eat it too. So yeah. So now when I run, in theory, since everyone's getting pushed on with the next offset of 0, in theory there's no problem and everything is good and it's all fine. But as you can see, like we get situations here where, you know, we're already, like I was saying, we have sort of artistic rules about the sort that we want enforced, and you can see we get situations like that, even though that's not ever really probably going to happen in the actual game, but it, you know, in the current state of the build, it can happen. So you take a look at that, and the sort order is messed up on the hero. We know the sort order should never be that, and we want to kind of just have it be regular. We don't want to have to start fussing with z values and hacks and that sort of stuff if we can avoid it. And so let's see if we can make that work by using the offsets that we just created. All we need to do is make a way to actually access them now, because now we are set up for daisy chaining through the system, and I think we'll be good. Okay, so inside render group, we have a way to push a render element and a sort key at the same time, but at the moment we don't have a way of pushing a render element without pushing a sort key, right? And we need some way of being able to push a render element without pushing a sort key. If we don't, then there's no way to do that daisy chaining. So if we take a look at what happened, right, when we do our push render element here, where are we at? Well, I guess it's neither here nor there. I think what I would say is probably when we're doing the push, there's a couple different ways we could do this, but I think the way that I would probably do it is I would just say like, hey, you know, we've kind of got this way of writing things in here for our object transform or whatever. Let's just say that in addition, that object transform that we're using, also maybe that would have the ability to record the last thing it pushed. So if you wanted to push onto the end of it, you just could. I don't know. We'll see. I guess I don't want to be premature at that. Let's just see what happens. So anyway, inside push render element that pushes this stuff on here, we also might want to have a version, and I guess I could keep it inline in the same sense, but you know, it doesn't have a screen area and a sort key potentially. That makes things a little trickier. This means we do have a choice here. I'm probably going to leave it at this for today, and we'll tackle this tomorrow because this is kind of interesting. We have a choice here, and I'm not sure that we don't want to maybe say, let's actually put that daisy chaining into the actual sort system. And the reason that I say that is, well, let's suppose that the hero looks like this. If we only have one sort entry for him, then the hero ends up looking like this. Even though these are the actual sprite areas that are being used, this area which is not being occupied by the sprite at all, and there could be quite a lot of that potentially depending on what the layer sprites look like. You know, imagine I had some big fat thing, right, with a teeny tiny head on it. Something like you might see in Binding of Isaac, right? Well, if we only have one sort key for it, it's going to have to be the union of the rectangles. Which means that all of this area is considered overlapping and will get sorted by the sort system. It will take anything that was under here and think it has to do sorting. I don't know if that's a good idea or not. I'm not sure. So yeah, so either we union them together, or we store them separately, and when it does the checking, inside the sort routines, it will go and check all the rectangles sort of separately for these composites. And it'll use the same sort key for them potentially, but it wouldn't use the same screen area. That's a tough one. That is a tough one, my friends. So, I don't know. I got 5 minutes. I'm going to play with this for a second. So when we do a push render element on here, you know, we've got the opportunity to do the command sort entry stuff or not, right? So we can decide not to do that. I don't know if I want the debug tag thing to be there. I think it should probably be here. And that way I'll put so if you take a look at what's happening here, we have the opportunity to sort of we have the opportunity to say, okay, you know, maybe we don't do this. And I don't know whether it would be a party foul to sort of not increment the push buffer element count. I'm not really sure if anyone cares about the push buffer element count. Because really, at this point, the push buffer element count, I think, is really only used for knowing how many things to sort and how many rectangles there might be en toto. In fact, why are we using the push buffer element count for the clip? Is that just a typo? That feels a little typo to me, would you not say? Because clip rect count is right there. Oops. It just feels like, you know, it feels like the clip rect count is the thing you want to use if you want to know how many clip rects there are, not the total number of elements. That just seems stupid. I think that was a typo. Anyway, so I think the only person who uses this is the sorting, and so maybe that should be renamed eventually as well. I'm going to mark that. Note Casey should push buffer element count be renamed behind my head. But yeah, so I think what we could do here is say, you know, if we are planning to, you know, if it's a new element, we do this. Otherwise, we would just need to merge the sort keys and the screen area with an existing one, right? So, you know, we've got all this stuff here. Got a sprite bound and rectangle 2 for the screen area. And so for the screen area, it's pretty trivial. You know, it's just going to be like screen area equals union, screen area, screen area. So there's going to be just some, like, you know, existing, something like this. Right? And for the sprite bound, since they happen to be min-maxes and stuff, I think it's similar. So I think existing, you know, bound, and there's my time, my time is up. Ymin equals minimum, you know, existing ymin or something. Yeah, again, I don't really know how we're going to store this exactly, but you know, we take the minimum of that with the sort key one. I would really wish that my little let's move that up above my utility so I can actually read it. You know, it's really just going to be something like this. So that would really be it, I think. And when we do that daisy chaining on there, then, you know, header next offset, we have to have a way of doing like, you know, the existing next offset equals whatever our offset was going to be. So it's, you know, the command's push buffer size. And then, you know, we would need to, at the end of it here, make ourselves existing. But that's it. So yeah. So I don't know exactly how we want to do that, but that's what we would do. And I think that leaves us compiling and running properly for tomorrow, or overnight rather. So that's all good. All right, people. Let's go to the Q&A. There's a Q&A for you. Let's take, so we got two questions here. Let me take them in order. Thanks to the grid partitioning, do we now have a convenient way of doing the graph sort in SIMD, possibly processing 4 grid squares or 4 sprites within a square at once, or is it not quite that simple? Well, you know, what I would say about that is your intuition is correct that you could do things of this nature, but we probably could have done that before, right? We probably could have processed 4 rectangle checks at a time. The reason that we won't probably do that is because, like everything else, SIMD optimization ends up making code super brittle and strange, right? It's really not great. Like, it's one of those things where C, certainly not C or C++, and not really assembly language either, they just don't make it convenient to code. It's not, the languages aren't right for it. And, you know, people have made sort of attempts to make sort of auto-vectorizing stuff, but it's not really where it needs to be, because usually the problem with vectorizing code is not the code, it's the data, right? And you need good ways of making the data look correct. And so to give an example, in yours, what you're asking sort of is like, can we leverage the grid for this? Well, forget the grid. Let's just say we wanted to accelerate the one we were doing before, where we did the n squared test, right? Well, we have a giant array, and we're going through the whole array testing. If we bucketed those up into groups of 4 and stored 4 rectangles as 4x's for 4x mins for x maxes for y mins for y maxes, whatever, right? Then you could do bulk testing. So in some sense, it would actually have been easier to do it there, because in the grid now we have to, as we're filling it in, we have to fill in the grid, you know, in that way as well, which again makes that the grid partition part more expensive, and the grids are less likely to be full, right? You know, a grid bucket might only have 8 sprites in it, which is 2 full buckets. Oftentimes it would have 6 and miss 2, you know, or whatever. That means that a huge amount of your processing is going to waste there. In the old way, we had, you know, 2,000 sprites. Well, most of all of the buckets of 4 are filled. Only it's like 0.01% that's not full, right? And so yeah, So, could you SIMDize it? Sure. Do we need to? No, because it's way faster than we need it to be at the moment. Because when we compile in release mode, we're at 60 frames a second. So, we'd certainly want to wait until we actually had a problem before we would go a SIMD route. And so I would say, yes, you could do it. No, I don't think it would be simple, not because there's anything complicated about the act of writing it, but because it will make the code and the storage stuff a little twisted and easier to put bugs in. And so that is unfortunately why it's usually not a good idea to optimize SIMD all the time, even though it would be nice because it would always be faster. Someday, I hope we will have languages that make it easy to write the SIMD code correctly, and we might, but we're not there yet. Okay. The mic DX, with regards to the flags and the order checking, if you are anding the flags with the ID to test if you have seen it before, what happens when another item does the same check and ands it with the same changed unit? Doesn't that make the result different to the check flags and mask equal ID for the new item? Did I miss something, or did you and the flags of the mask before you set the idea to clear it first? So I'm not sure I'm 100% clear on what you're asking. I think I might know, but I might also not know. Let me explain it. Let me just walk through it once, and then you can tell me whether this answers the question or not. Okay, so the code in question is right here. The code in question is b flags and sprite index mask not equal to node index A. Assert node index A, and sprite index mask equals node A. Assert b flags and non-expect equals 0. B flags equals node index A. That's the entirety of it. We can ignore the rectangle intersect check because obviously that's the check for the rectangles overlapping. That's not relevant to the prevention code that we're talking about here. Okay, so let's take these one by one. B flags and sprite index mask not equal to node index A. What is that actually doing? Okay, so let's pop back here. Right. So we have the flags. I'm going to close that down. There we go. So we have the flags. We're anding it with the mask. And then we're doing not equal to node, not equal to A. That's what we're doing. Right? So what does this do? Well, what this does is it gets rid of anything that might have been in the flags field. Now, mind you, it's not strictly necessary. And the reason that it's not strictly necessary, and I could even put a note here. It's not strictly necessary because really, we're never setting those flags up above here. So I was just being a little overly tidy, and because an and is extraordinarily cheap, like extraordinarily so, in the context of what we're doing here, I just did it for safety's sake, right? But it's not strictly necessary. We could have just said b flags not equal to node index A because there's nothing in the upper 4 bits, the upper 4 bits that we reserved for flags. They're all 0 anyway. So the and is superfluous, right? Because what this and does is it says, well, all right, what I had was a thing that was partitioned like this. Here are the flags, the actual flags, right? And here's the index. And so what I wanted to do was I just wanted the index. This mask is 1s all here and 0s all here. So the and leaves me with just the index. If there was anything in the flags, they are now gone. So the flags field and the mask, basically that's just getting rid of the actual flags and leaving us with just the index part. And then we compare it against A to see if that's what it is, right? So hopefully that's clear. All that and mask is doing is getting rid of any flags from the upper part, which we know there aren't any at the moment, so we don't even really need to do it. Okay, so next part. And these assertions are just checking, we'll put the assertions aside. These are just checking some assumptions, right? So then we just do b flags equals node index A, right? And you know what, I guess in this particular case, since I preserved it here, you'd think I would have, I think I even said I was going to, and then I didn't. Oh, and you know what? No, now that I think about it, these assertions that we're doing, I actually just asserted that they actually do equal 0. So this is not necessary. Never mind. We don't even need the and, right? It's superfluous because I asserted that we didn't do it yet. So rather than putting the and in, and this is probably smarter, I'm not sure why I didn't do it, why I didn't just leave it out in the first place, is just say that the flags have to not be there. Because then that way we didn't write the routine in a slower way because we might do something later. We put an assert in there that would catch it, so if someone up above us starts to try to use the flags, it'll assert in here instead of it just going wrong and them going, I don't know why, right? If that makes sense. Okay, so now hopefully this makes a little more sense to you since the mask is even now gone. Although I just explained what it was doing, you can ignore that because we don't even have to do it. So we say bflags is not equal to node index xa, so that means the field inside the rectangle we're checking against is not set to our field, right? If we assume that it fails that check, right? So, you know, not it fails that, it succeeds in not finding it, right? So it's the not equals. It's saying the node we're checking that we're on the pass through, when we go to check, I should say this more clearly. A, who is the rectangle we are checking, and B is the rectangle we're checking against. If B does not have our index in its flagged field, then we will proceed, right? If it has anyone else's, that means it was from a previous iteration. When we get in here, we say, okay, now we're going to set the flags field equal to node index A, right? So now we have marked it that we're visiting it on this pass. Now remember, all of our checks for index A will happen in one loop. So we will never check index A again. So every other rectangle that we happen to touch, we will leave our marker in them, and we will not touch them again if we see that marker. When we move to the next index, well now, remember we're checking for equality with the index that we're on, right? We're saying it has to be not equal to that one. Well, just because now there's a bunch of cruft in all of those flags fields that are previous indices that we checked, right? Yeah. It doesn't matter because we're checking against node index A. I did just think, however, there is one problem with this that's kind of hilarious. It's like I don't have a bug, I don't think, but it's only because it just so happens to not be a bug. Like, I wasn't smart enough to not have the bug. I wish I was smart enough to have thought of the fact that this isn't a bug, but I didn't actually. And what that is you'll notice this fails in one case, and that is the case when you're on the first index. Because all of the flags fields will be set to 0, and so every one that you check, you'll go, oh, I already checked it, so, you know, I shouldn't check it again. Hilariously, there will never be anyone in the grid on pass 0 because you haven't added anybody yet, right? So it just so happens that the field that we picked, the value that we picked to represent the initial state and the time when that initial state would have caused a bug, they perfectly line up, and so there is no actual bug. Does that make sense? So that's a separate thing. Good Pals 6. Will we ever do any network programming on Handmade Hero? No. I will not, anyway. Brian Wag, I love how you said we don't want to solve this with hacks for a particular sorting condition. Do you think the engine should cover most all boundary conditions, or is there room for boundary hacks in certain extreme circumstances? Did I say that? That may have been a misstatement. Or rather, I may have not been trying to convey that. I think what I was probably trying to say is a particular thing we may not have wanted to hack for a particular reason, and I don't know what context I said that in. But the concept of fake 2D sorting is all a hack, right? Like, really you need full 3D objects. You can't have sprites and ever produce real sorting. And the reason for that is that, like, you don't have the information you actually need to do a correct sort, right? I mean, take a very simple example. Take, a sprite that's supposed to represent a pyramid, right? Well, if there's somebody standing right here, are they in front of or behind the pyramid, right? The answer is the only way you could have known that they're supposed to be in front of the pyramid there is if you had actual 3D depth information for this pyramid and depth information for this and knew that it happened to be the case. Because otherwise, it should be behind. Certainly, it should be behind if he was here, right? If you just slid him over, he's behind. So the same two sprites with the same rectangles overlapping in basically the same way, you wouldn't ever know how to sort them unless you had actual 3D data. And so the whole concept of 2.5D sorting in this case is a complete hack. And so we just have to do something that is reasonable. And we've sort of, I guess, gotten to that point now. But by no means would I ever say that it was some kind of a beautiful, pristine engine concept here. I don't think there is one for 2.5D sorting. I think there's just coming up with hacked rules that work for your particular circumstance, and then maybe doing a good job on the algorithm that implements those rules, like I think we did. We did a reasonable implementation there. It's not the best. We could spend weeks making way better ones, but it's totally fine. It doesn't run n squared because we've partitioned it. It only does the graph traversal once. It detects cycles properly. It's not a piece of crap, right? And so I think, that's maybe more what I was saying is there's some, we don't want to hack stuff we don't have to hack. If there is a good solution, maybe we should do it. But the thing in general is a hack. And so your follow-up question, do you think the engine should cover most all boundary conditions, or is there room for boundary hacks in certain extreme circumstances? The whole sort rule is a hack. So, that is just, I think, unavoidable, unfortunately. All right. Cool. All right. So let's go ahead and close down. Oh dear. Guess I didn't save something. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along at home with the source, you can always pre-order the game on handmadehero.org, and it comes with the source code, so you can play around with it. Even as it is still in development, you can do your own little tinkering. We also have a forum site you can go to if you want to ask questions, a Patreon page if you want to support the video series, a schedule bot that tweets the schedule at you if you want to catch us live, and an episode guide if you need to go find that very special old episode you missed. It's all there, and thanks to Miblo, the magical god of annotation, it's even marked up with timecode, if you can believe that. So that's about it. I'll be back here tomorrow at 5 p.m. Pacific Daylight Time, when I think we'll have to make that decision about what we want to do with the sort of daisy chain sorting. I don't know what the right answer is to that. We don't have a lot of information. Maybe we'll leave it like it is right now and just implement the merging, and we'll see if that causes problems, and if it is, then we'll sort of move it out. Because it obviously makes the sort cheaper to have less things in it. So if you can get away without it, maybe the answer is get away without it. But on the other hand, when the hero stretches around, it's going to be bigger. I don't know. The more I think about it, the more I'm thinking, talking myself out of it, maybe we probably should actually put them on there. Anyway, that's about it for today. Until tomorrow, have fun programming, and I'll see you guys on the internet. Take it easy, everybody.